Hello, everyone. We are going to go over the last two review sets from the first section of the study guide today. So let's go ahead and start that right away. Problem number one, the first problem on this section, says to factor x squared plus 6x minus 27. The way we talked about factoring this year is to use the box method. Remember, with the box method, we are working inside out. So when we have the box, we are going to put the A term up here and the C term down here in the bottom right. Just a reminder, this is in standard form, so it's ax squared plus bx plus c. Okay, so the A term is x squared. Let's put that up here, x squared. The C term is negative 27, negative 27. And now we're going to work inside out. So our goal is to fill out what goes up here on the top and what goes over here on the side. So we're looking for, start out, two things that multiply to make x squared. That one should be pretty easy for all of us. It's x times x. And now we're looking to fill in the rest of this area model. We're looking to fill in the rest of this box. And so what does that mean we're looking for? Well, we want two numbers that multiply to make negative 27. Now here's the trick. Those same two numbers need to add to make whatever our b value is. In this case, our b value is 6. So add to make 6. So this is where you would use a calculator or a table or a multiplication chart or something like that to find those two values. Two numbers that multiply to make negative 27 and add to make positive 6. And after a little bit of work, you would find that that is 9x and negative 3x. 9 times negative 3 makes negative 27. 9 plus negative 3 makes positive 6. So from there, we can work inside out again. Here we have an x, and what times x makes 9x? Pretty clear that should be a 9. And then over here, again working inside out, what times x makes negative 3x? That would be negative 3. Therefore, what you see here on the outside are my factors. X minus 3 times x plus 9. All right, you guys. The next problem says, what is or are the solutions to the following quadratic function? Well, remember, solutions, the way we did this in this year is we solved by factoring. Solve by factoring. So we're going to do the exact same thing we did on the previous problem, except we have one additional step after we get our factors. All right, so let's do another practice round of that. Do our box method. X squared, the A term on the upper left. 36 is the B term on the bottom right. And we need to find two numbers that multiply to 36 and add to negative 12. Again, guess and check, figure it out. There's lots of ways we talked about how to do this year. Use a calculator, but when you realize, after you find them, negative 6x, negative 6x, negative 6 times negative 6 makes 36. Negative 6 plus 30 or plus negative 6 makes 12. So working inside out, this is x times x. This is negative 6 times x right here. This is negative 6 times x over there. And my factors are x minus 6. Get that out of the way. X minus 6 times x minus 6. We want to, here's where we can need to continue. So we're going to go one more step here. We're not just factoring, we're solving. So in order to solve, we want to find out what number would you plug in right here and what number would you plug in right here to make that binomial equal to 0. And you could probably do that in your head. 6 minus 6 makes 0. This other one happens to be the exact same, so this answer is also 6. The other way you could do that is to set the binomial equal to 0 and then solve to get x equals 6. And that is your solution. Okay, don't stop at the factors when it says to solve. Find the solutions. X equals 6. All right. The next problem asks us to describe in words how you would find the solutions to that equation. So that's pretty much exactly what we just did on the previous problem. So let's type that in and I'll just kind of say it in words. We would first factor the trinomial to get, and then again, you look here, I need two numbers that multiply to make negative 20 and add to 8. So the factors would be x plus 10, x minus 2. Then set each of those factors equal to 0 and solve to get my solutions of x equals negative 10 and x equals positive 2. All right, so that one you're not actually solving, you're just describing how you would solve, writing it in words. All right, and that is on those. So let's go ahead and jump to our last review set of this review slides. Review set 8 is all about the vertical motion formula. So these are those word problems we did throughout the course of the year. So the vertical motion formula is h of t is equal to negative 16 t squared plus v sub 0 t plus h sub 0. From our notes in the past, I'm just going to answer the first two based on those. So which variable represents the starting height? Well, remember that h stands for height, so you can see there's an h here and there's an h here. So which one of those represents the starting height? Well, remember from our notes, that's what that little sub 0 represents. That means like initial or beginning. So h sub 0 always will mean height initial or starting height. So we can type that in. I'll use the equation so I can do the little sub 0 in there, and there we go. So based on that information, it's the next question asks, what does v sub 0 stand for? Well, remember with vertical motion, it's a parabola. So we have, I'll use this color, we have a parabola. Something gets launched into the air and comes back down, and here's the ground right here. Oops. So what things do you need to launch something into the air and have that shape? Well, remember, you need to have a starting speed. You need to be whatever you launch it at, and then gravity is going to pull it back down. Start speed. So it's going to get launched with the starting speed, and then gravity is going to pull it back down. So what does V sub zero stand for? V sub zero stands for that starting speed. It's how hard the ball is thrown or how hard the item is launched into the air. It's V for velocity. So V sub zero is your starting velocity, which I'll remind you is the starting speed. Okay. Now let's do some of the actual problems. So here is an equation that represents the path of a ball thrown off the top of a building. So just a reminder what we just talked about on the last one. The A in vertical motion is gravity. The B, which is not really B here, right? We know it's V sub zero, but if you think of this as AX squared plus BX plus C, then we can call it the B. Same thing. The B is the speed at the beginning, which will change, right? Because it's getting launched into the air, so gravity will affect it. And then C is the starting height. So basically, if you're standing above ground or below ground, it's where you're launching from. All right, so based on that, you can see here that the gravity is negative 16 feet per second squared. It's launched at a speed of 80 feet per second, and it's starting at 96 feet off the ground, a very tall building. The question number or letter A asks you, how long does it take for the ball to hit the ground? So where would that occur? Well, as we've said before, let's just kind of sketch this out here. You have this really tall building. It's up here. The ball gets launched in the air and then it comes down and lands on the ground. So how long does it take to hit the ground? Well, that's going to be the time from here to here, right? Time. And as you can see, that is represented by the x values or the t values. So you are trying to find this point right here, and specifically the x value of the point. That has a specific name, that point, and you can see it is the X intercept. It is where the ball lands, and the x-axis is the ground, so that point is the X intercept. So all we need to do here is to find the X intercept. All right, so I can jump into Desmos with that. When I graph that, I know it's on a different slide, but if I plug this into a graph, which is what you guys would do as well, and you look for the x-intercept, you find an x-intercept of 6. So how long does it take for the ball to hit the ground? It takes 6 seconds. And again, if the ground is the x-axis, then that you're looking for the x-intercept. And how do we find x-intercepts? We could do it by factoring, which is what we did on the previous practice set from earlier in this video, or you could do it by graphing and looking for the x-intercepts, which is what I would have done in this problem. All right. How would the original equation change if the ball was thrown from a 4-foot hole in the ground? So instead of being thrown up from up here, the ball was thrown from underground, right? Is like actually down here. Well, instead of, if you come over here and remember the starting height is C, instead of being 96 feet above ground, it's 4 feet below ground. So the equation would change because by the C value would become -4. So H of T equals negative 16t squared plus 80t and minus 4 for your C value because it's 4 feet underground. All right, moving on to the next problem. A cell phone is dropped from the third floor of a building 48 feet off the ground. Dropped is the key word there. What does that help us with? Well, gravity is always constant, right? We say gravity is negative 16. Getting a little glitchy here. There we go. Gravity is negative 16. Ay, ay, ay. You guys, it doesn't like me. Oh, I see what happened. Negative 16. Then